Hi, and this is a introduction to section 9.5. In section 9.5 on page 583, we're going to learn to factor a trinomial that has a lead coefficient of 1. And that's a concept that some people breeze through, some people struggle a little bit with more. So I want to introduce that section by showing you factoring trinomials with algebra tiles, all right? And I found this little PowerPoint online, and I think it's a nice PowerPoint. And if you want to look on page 582 of your book, that's the kind of problems we're going to be working on, page 582, and maybe I should quickly show that right now. Okay, so I'm just going to write that down, page 582. And this little PowerPoint I found online is a really good thing, a really good way to show how to factor a polynomial. So we're going to start with something really basic, even before a trinomial, just this binomial, 2x plus 6. Okay? So it says here, when factoring, place the problem inside the grid. The answers will be found on the outer edges, maintaining straight lines within the grid. So in other words, I want to take 2x plus 6 and arrange it in here. Now remember before, when we multiplied polynomials, I had you start by framing the multiplication out here. Well, when you're factoring, you do just the opposite. So I got to take 2x plus 6 and put it inside here. All right? So let's do that. And when I do that, what you want to do is you want to frame this in a rectangular shape. Now you notice if I would have put these 6 single unit tiles down here, I would not have made a rectangle. So I want to arrange these in a rectangular arrangement. Now once I arrange them in a rectangular arrangement, and before I click on this, I want you to notice, do you notice here what I have, and let me actually get out tiles to show it, and they're going to actually do this on the video, or on this PowerPoint in just a second. Let me get out some tiles. You notice that first of all, what I have here is I have 1, 2, 3 tiles here, and then I would definitely need 2 unit tiles here, and then I would have one more of the bigger green, we always use green for ours, the green unit tiles. And what I'm finding out is that if I took x plus 2, x plus 3 I meant to say, x plus 3, here's x plus 3 on top, times 2, I would get 2x plus 6. And let's check that out. If I take 2 times x plus 3, am I actually getting 2x plus 6? And yes, I am. So the key here is to start with a rectangle inside and then frame the exterior with what I would need. So can you see how I have, this is a length of x. This is one of my x tiles, and I got 3 unit tiles here for 1, 2, 3. And then these are just my unit tiles. So x plus 3 times 2 would give me the proper factorization of this. So let me turn this back on so you can actually see this at work now, and you'll see that happening. So there's the 2 unit tiles that they're framing. There's the x plus 3, and these factors are found on the outer edges. It's 2 times x plus 3. When you remember, when you're factoring, you're trying to find what is the product that creates 2x plus 6. Well, 2 times x plus 3 would create 2x plus 6. Okay? Let's take a look at this one, 3x minus 9. So first of all, I'm going to put 3x tiles in here and then 9 negative tiles. Okay, so there's 3x tiles and 9 negative tiles. And remember, you have to create a rectangle in here. If I would have put these 9 tiles down here, I would not have created a rectangle. So with that said, next, we're going to start framing this. I'm going to put 3 positive tiles here, and I'll do x and 3 negatives here, and they're asking, is there more than one correct answer? They're going to take a look at this. Definitely a correct answer would be 3 times x minus 3, because if you distribute, you get 3x minus 9. Okay, let's see if we can get one more correct answer. And let's try this one out. What if we put the 3 negatives here and we put a negative x tile and 3 positives here? We would actually get 2 correct answers because negative 3 times negative x is 3x and negative 3 times positive 3 is negative 9. So I guess there would be 2 correct arrangements for factoring 3x minus 9. Now, this is what the book is going to get into more today, okay? And the last 2 that I showed you, we were basically just undistributing is what we were doing, which we've already practiced in Chapter 9, but I just showed you that in algebra tiles. Now here we're going to factor a trinomial, but it's the same idea. We want to arrange x squared, 5x, and 6 in here, and we want to arrange it in a perfect rectangular shape. So we're going to get out x squared. And now to get out 5x, what I would normally recommend is this, and maybe I shouldn't have turned this slide on. Let me actually do this. And this is when people struggle on this, they have a hard time arranging the rectangle. So let me do that with you first. Let's arrange the rectangle. And I'm going to do that real nice and big. So first of all, we got this huge x squared tile, which on our tiles were actually in blue. So I'm going to arrange this huge x squared tile here, just like they did on the screen, okay? And now I want to arrange my x tiles. Okay, so this is what I would suggest you do to arrange them, okay? I'm going to try this first. Here's an x tile. Here's an x tile. Here's an x tile. And let's arrange all 5 like this. Now remember, our x tiles are green. They're using pink on this. Okay, and then I got to get out 6 of these unit tiles. So I'll try to make these as best I can. 1, 2, 3, 4, 5, and 6. Well, you notice if I arrange them in this manner, there's no rectangular shape. Okay, so what I can do then, is I'm going to start dragging these things and trying to twist them. So I know I can twist this somehow. How can I want to twist this. And how can I do that? I'm going to pause the videos till I learn how to twist it. Just a second here. Okay, I'm back. I just figured this out. So what we can do here is we can arrange this and put it here, okay? Well, let's see if that works now. If I do that, well, I can definitely fit this one here, and this one here, and this one here, and this one here, and you notice, ooh, I got a perfect rectangle here, but then I got these 2 extra tiles left over, and I still, I can't put these, I still don't have a perfect rectangular shape. But what if I do this? What if I steal one of these here, and I twist it, and I place it down here? Well, now suddenly after I do that, I can move this tile here, this tile here, and this tile here, and now I have the same arrangement they showed you on the slide. So there's the proper arrangement. I have a rectangle made, okay? And now all I have to do is basically figure out what is here and what is here and corner this in, and now we'll find out the factoring. So let me turn this back on. Okay, so now let's do that. As you can see, I need x plus 2 here, x and 2, and up here I need x plus 3. So the proper factoring here, and my pen isn't, there we go, my pen wasn't responding, it would be x plus 2 times x plus 3. You can see it, x plus 2 times x plus 3. Let's do one more. X squared minus 6x plus 8. So first of all, I got to get out x squared, a big x squared tile. I got to get out 6 of the negative x tiles and then 8 of the little positive tiles. So I'm going to do that first. There's my x squared. Okay, now maybe I should have done this again. I should maybe arrange this out again. First of all, if you, and I'm just going to quickly maybe draw this out. Well, I don't have to draw it out. I guess I will use these again. Okay. Remember, if you go ahead and you get out the red negative tiles, and I'm going to arrange a couple here. If I did this arrangement first, I would have these 8 tiles sitting off to the side, or I should say this, if I try arranging it this way, I'll have these 2 tiles here, and the problem is there's 1, 2, 3, 4, 5, 6 of the tiles, but I have 8, which means there's 2 more left over out here that I can't arrange in a rectangle. So remember, if I take one of these, I want to undo that. Screwed up. There we go. If I take one of these tiles and I just go ahead and twist it and place it over here, the nice thing about that is it would allow me to put 1, 2, 3, 4 tiles here, but remember, there's supposed to be 8 of them. Now there's 8 of these floating around that aren't helping me. Actually, I guess I could have said if I put that there. I got space for 1, 2, 3, 4, 5, but there's 3 yellow tiles that I can't arrange anywhere. So the next thing would be to take this tile here, and if I turn it and put it over here, now I do have room for 1, 2, 3, 4, 5, 6, 7, 8 tiles arranged, and these tiles I could just actually get rid of. Can I get rid of it? I don't know how to get rid of it. I'll just move them out of the way. Those aren't there anymore, and there's your arrangement. I have x squared minus 4 along the top, and I have x, I misspoke, x minus 4 along the top, and x minus 2 down the side. And let me actually show that. So here's my x minus 2. Now remember, our algebra tiles are green for the x tiles and blue for the x squareds. They're using pink and green. And then across the top I have x minus 4. This is x minus 2 times x minus 4. Let's do one more. We have x squared plus x minus 6. So first of all, I got to get out that x squared tile, and that minus 6. And you notice that's not working. Okay? So what the heck am I going to do if this isn't working? This is one of the tougher ones. Now remember, here's the little hint. Remember how we had a 0 pair? Okay, think about a 0 pair for a minute. A 0 pair means that if I go ahead and I get out, and they're going to show you this on this little PowerPoint in a minute, but think about this for a minute. If I get out one red tile and one green tile, in reality, that's getting out 0. That's not, those offset each other or cancel each other. That's actually 0. So what I could do here is I could get out a couple reds and a couple greens. Let me do that. And let me get out one more red. And does it make sense that if I get those out, I haven't added anything because these combined make 0. These 2 reds and these 2 greens make 0. Well, I think you might get an idea of what we could do. We could take, and I shouldn't have done that. I got to get rid of that. There we go. I could take these 2 reds now and arrange these down here, which I think you'll see on the video in a minute, or on the PowerPoint. Take these 2, arrange them down here. Because remember, when I took out 2 reds and 2 greens, that's 0. Adding 0 doesn't affect anything. And if I just move these over here, now remember, I'm using green because that's what our algebra tiles would be. They're just using pink, so this would be like another green. Well, you see how I have this set up now. And I still only have x tiles because I have 3x and I have negative 2x, and that's just 1x. So let me actually go back to the PowerPoint and let you see that in action. So what they do, we need to fill in with zeros like I just talked about. There's one, that's 0 right there, and there's another set of 0, and you can see now that when we do that, we get x plus 3 and x minus 2 as our factors for this, okay? I'm going to stop my video there. That should at least get you going. You have your algebra tile sets, or that paper set with you that you can play with these, and the assignment is just on page 582. We're factoring some trinomials here that have a lead coefficient of 1. And then on page 592, there's another 6 or 7 problems. I'm actually going to have you practice factoring those, but those have a lead coefficient of something other than 1. They do put examples above there that you can use to also help you guide through this. Obviously, if you have questions, we can talk about that in class tomorrow.